Okay, now, we're going to look at graphing this. Now, the first 5 parts of this had absolutely nothing to do with calculus. It was just finding intercepts and things like that. Now, this is a cubic equation, which is a polynomial equation. So what have we said about the domain of a polynomial equation? It's all real numbers. Domain is going to be for all real numbers. So I'll go ahead and state that. And if I show that symbol, y'all recognize that, right? All real numbers, okay. Now, that's beautiful. Y-intercept. How do we find the y-intercept of a function? Yeah, plug in 0 for x. So if I plug in 0 for x here, what do I get? 1/3. So my y-intercept is the point 0, 1/3. Very good. All right, we're almost there. I think we can do the graph from here. All right, we said we're going to skip the x-intercept part. Number 4 says we want to find all vertical asymptotes if possible. All right. What would I have as far as vertical asymptote is concerned here? What?
None.
Why aren't there any?
Because
Yeah, my domain's defined everywhere, so I'm not going to have a vertical asymptote. All right? In behavior, that means oblique or slant or horizontal asymptotes.
None. Okay.
You're right, none.
Okay.
None. Now, or. That little thing. Those 2 letters there. That's OR. I'll tell you, I've asked for handwriting for Christmas, so hopefully I'll get it this year. All right, so horizontal or oblique asymptotes, there are none. Are we good with that? Okay. Now, we can start the first derivative now. Why would I be interested in the first derivative? What is the first derivative going to possibly tell me? Slope, right? It'll tell me where we are. Increasing, very good. Or decreasing, all right, very good. Now, so y prime is going to equal to x squared x minus 2. All right? So to find my critical numbers, what do I do with this? Set it equal to 0.
So you just drop the denominator.
Just like bad habit. What denominator? Oh, the denominators go out because if you multiply 3 times 1/3, you get 1. 2 times 1/2 is 1. That's right. I didn't just drop it. It went away. All right, JP, if you don't do that again, it'll be fine too. X minus 2, x plus 1, right? So we get x equals, and x equals -1. What are those values?
Critical numbers.
Those are my critical numbers, okay? So, plug those in on my number line. Negative, yeah. All right, -1 and 2. Plugging those in on my number line. I'll go with -2, 0, and 3. All right. Again, I'm going to plug into this one. If I plug in -2, that's going to be a negative times a negative, which is positive. So what does that mean? We're increasing. We haven't gotten to the second derivative yet, so we're not doing concavity quite yet. All right, if we plug in 0, 0 minus 2, that is negative times a positive is negative. So what are we doing from -1 to 2? Decreasing, okay? And then finally from 2 to infinity, we plug in 3, we get times, which is?
What's positive?
Very good.
What is that?
DEC. Did I say anything?
I said,
My handwriting is not good. I know.
Maybe you should,
Wait. What
maybe
now?
you should write a letter to Santa saying you want everything right.
Or he replies to
You
because
might
I
be able
wrote
to
one
Santa
in
take you more
fourth grade.
seriously.
If I did this,
Oh, you know what I'm gonna do? I'm gonna give him handwriting for Christmas.
Even if you can't read it, let's look at it.
Exactly.
Very funny. All right, now before we back to me. Before we get off topic here. All right, we've done the first derivative. I've got my critical numbers.
You need the second one.
What about my points?
plug them into the original.
So what do I get when I plug in 2?
You,
8 over 3
2 cubed is
8
8 thirds minus
minus 2
2 minus
4
plus a third. Okay, so 8 thirds plus a third is 9 thirds, which is 3. 3 minus 2 is 1 minus 4 is negative 3. So what's one of my points?
Negative 3
2 negative 3. All right. What is that going to be as far as relative or absolute?
Relative.
Absolute.
Are they input?
It's going to be relative.
Relative. Because
Now, max or min?
that is.
Why do I know it's a relative minimum?
Because it's negative 3. The y is
Decreasing on the left, increasing on the right. Are y'all okay with that?
okay, yes.
You are? Good. Any? Khalil, you fired up? Okay. All right, let's go with negative 1. What do we get when we plug in negative 1 here?
the 1/3 cancel out.
No.
They go with
They smoke dodo birds, right?
Yeah.
All right. So, well, it's getting recorded. So then it's 2 minus 1/2, which is,
1 and 1/2.
but we like improper fractions.
3 halves.
3 halves, okay. So what is this point?
Negative 1 3 halves.
Negative 1 3/2. Very good. Is there a question about that?
That's it.
It's not a relative, nothing.
Y'all get picky.
What was the question?
That's good. I like that. That's one. All right, what's your question?
What were we supposed to find that?
All right,
What we were those are what are those?
talk.
I was asking.
Oh, I thought you were giving the answer.
Critical.
I said, what are those?
Oh, you said what are those? Okay.
Touching me.
Yeah. All right. What we've got is we got the critical numbers, right?
I just want to know where we were stopping. Like, what was the question? What are we supposed to find?
Okay. Well, I'm getting the critical numbers so I can find out my maximum and minimum values on this graph. So by taking my critical numbers and plugging them into my original function, that's giving me the exact points. Instead of me just knowing I have a maximum or instead of me saying I know I have a minimum at 2, I know the exact coordinates of that minimum.
So the question was to find where your critical numbers are.
Yeah.
Okay.
And the actual points.
Okay.
Yes.
So what made this different from the other problems that we've done in the past where we just had to find the...
Because we're about to graph it.
And that's why we need to know the vertical asymptotes more than that.
Yeah.
Yes.
Yeah, we're trying to find all this information so we can get this shape filled
So
in.
So if
negative
we were
1.
graphing the other ones, we would have to figure out...
Yeah.
Negative 1 3/2 is a relative max.
Yeah, that is a relative max. Because we're increasing to the
Decreasing, yeah, left and decreasing.
and decreasing to the right. Okay. So we've got 3 points so far. We've got my y-intercept. We've got our one relative minimum, we got one relative maximum. All right, what do we need to go after next? Concavity, right? And what do we do to figure out concavity? Second derivative. So, what is y double prime? 2x, what?
2x minus 1.
Minus 1. So, I get
X equals 1 half. X equals negative 1 half.
1 half, yeah. Alright, are we okay with that? Alright, now. What do I need to do with that 1 half?
Plug it into the original equation to get your x.
No, it's not your x-intercept. What are we finding here?
The graph.
Point of inflection, right? Okay, so I want to plug it into the original to get my point of inflection.
Push it all the way at the top.
Yeah, all the way at the top now. This one isn't as fun to do because we got a fraction. So anyway.
So let's
All right, what is 1 half raised to the third power?
1
Oh, sorry. 1/8?
But if we make it a negative,
no,
It should be positive 1 half. Are you good? Okay. 1 half times 1/8 times 1/3. Because it's 1/3 of it, so I just did that. Minus, okay. What do I get when I square 1 half? So it's 1/4 times 1 half. Minus 2 times 1 half, which is 1. And then plus 1/3. Right? Okay, so let's see. We've got
you said.
what?
Okay, never mind.
Okay. 1/24 minus 1/8 minus 1 plus 1/3. So let's just make that minus 2/3. No, yeah, minus 2/3. Save a little time. Oh yeah, this problem is brought to you by this company here, from which I stole their patent. All right, so what do we get? It's 1/24
324.
minus 3/24, then minus 16/24, which is
And 1 minus 3 is
that's negative 2, negative 16, negative
18/24. Simplifying it. And that's 6. 8.
negative 3/4. Very good. So I get the point 1 half negative 3/4. Is there a question about that? I couldn't write that down because I was running out of room. But I think everybody's got that, right?
that's the point where the concavity changes.
Yes, that's the point where concavity will potentially change. And if we do plug that in on the line, here's 1 half. All right, plug in 0. What do we get? Positive or negative? Negative. So it is concave down. And then plug in 1. Plug in 1. Positive, so it is concave up. All right.